Our final project is validation of GhostNet lightweight convolutional neural network on CIFAR-10. I'm Fei Yuhan. I was responsible for selecting the topic, reading and understanding the main content of the paper, part of coding implementation, as well as writing the report and recording the video. And my partner's name is JN Zhang. He was responsible for the part of the coding implementation, debugging and summarizing the experimental results. This project is divided into two parts. One is to read the paper and understand the key contents. The other is to code the implementation and perform the verification. First is the core content of the paper. This paper describes a new method for constructing feature maps of convolutional neural network. They found that there exist many similar parts of figure maps. The output feature map of convolutional layers often contain much redundancy, and some of them could be similar to each other, as shown in Figure 1. They found that, given the instinctive feature maps from the first part, a series of similar linear operations are applied for generating more feature maps. Then we know that instinctive feature maps executed linear operations to get ghost feature maps, and cheap operations just like the linear transformations. Ghost module is divided into two operations to obtain the same number of feature maps as normal convolution. That is shown as a figure. In experimental section, we trained the VGG16 model and its ghost replication version, ghost VGG16 models. This is done by replacing all the convolutions in it with ghost model for VGG16 and named it ghost VGG16. The structure is relatively clear, divided into 5 steps: data, module, loss function, optimizer, and training. The model is the most important part. Model definition is shown as below, and the loss function and optimizers are shown as below. We can find that there is no significant decrease in accuracy after using GhostNet, which is consistent with the paper. For the other part of the experiment, we calculated weights and FLOPS. With the help of Torstar library, we calculate the weights and flows. After using Ghost, weights and flows basically dropped to half of their original size, which is basically in line with the paper. Let's conclude with a summary. In this project, we learned the definition and the extraction of a new convolutional neural network feature map by reading, simming, and experiment, and verify it by experiment. This project enables us to better understand machine learning and convolutional neural network related to techniques, and improved our paper reading and programming skills.